Hi, and welcome to the first of my series on fractions. Today we'll be reviewing the basic concepts of fractions. Let us first begin our lesson with a definition for fraction models. Fraction models are simply ways in which fractions can be represented. For the purpose of the PCR curriculum, we would restrict our various forms of representation to the major models of representing fractions. There are three major models. These are the area model, the set model, and the linear model. Let us look at the area model. As the name suggests, this involves the use of area. Here, fractions are used to represent area of two-dimensional objects. Take for example, if I had this pizza. Suppose this pizza was cut into 8 equal slices, and this pizza had an area of 8 square units. Then this means that each slice of pizza will be equivalent to 1/8 of the total area. So that 8/8 will be the whole. But suppose if I wanted to take 4 slices of pizza and give it away, then 4 slices of pizza will be represented as 4/8. But if we were to look carefully, removing 4 slices of pizza, we will see 4/8 is the same as saying a half. Now let us look at another model. Let's look at the set model. The set model places physical objects into sets, and these sets are represented as fractions. The total number of objects in the set represents the whole, and the part of the set represents the fraction. Take for example, if I had a set containing 8 marbles, the entire 8 marbles will be referred to as the whole. This is equivalent to 8/8. Now if I were to remove 4 of the marbles, 4 of the marbles would be represented by 4/8 or a half as seen before. Let us look at another model. Let's look at the linear model. The linear model uses fractions to represent length. For example, if I had this ruler, and this ruler happens to be 8 centimeters long, then the entire length, that is 8 centimeters long, is equivalent to the total or the whole. And we recall that the whole here will be 8/8. Now if I were to use 4 centimeters from this length, then the 4 centimeters would be represented as 4/8. Recall that the whole consists of 8 parts, so that measuring 4 centimeters out of the 8 is represented as 4/8. And we said 4/8 is also equivalent to a half. Now we will be exploring equivalent fractions using the 3 major fraction models. Let's first start with a definition. Equivalent fractions are fractions that are equal to each other. Looking at the area model first, we would use a fraction wall to explain equivalent fractions. This is a fraction wall. So, let us see if we can derive equivalent fractions to a half. If this is a half, we are going to look and see whether we can find other strips or a combination of other strips so that we would have the same length and width as a half. Note we can use 2 quarters. 2 quarters has the same length and width as the half strip. So we can therefore say a half is equivalent to 2 quarters. What about the sixth? Can you say how many sixths will be equal to a half? If you said 3 of the 6, then you are correct. Because 3 sets of 1/6 is equivalent to a half since they have the same length and width of the half strip. What about the eighths? How many eighths would be equivalent to a half? Well, if you said 4, you are correct. There are 4 1/8 in a half. Note carefully, 4 1/8 or 4/8 lines up with the half since they have the same length and width. Now, we can conclude that a half is equivalent to 2 quarters, which is equivalent to 3/6, which is equivalent to 4/8. Can you say how many 12 is equivalent to a half? If you said 6/12, then you are correct. There are 6/12 in a half. Now let us look at another model. This time we are going to use the set model. Suppose if we had this amount of marbles, 12 marbles, we can say this is a set consisting of 12 marbles. The whole therefore is 12. But what if I were to divide this set into 2 equal parts so that each part would have 6? We can see this is equivalent to a half, and a half is also equivalent to 1, 2, 3, 4, 5, 6 marbles out of a total of 12. So we can say a half is the same as saying 6/12. But what if we were to evenly divide these set of marbles in another way, like this, so that we'd have 4 equal divisions of the same set of marbles? Then each one of these sets would represent a quarter. But if we were to look at the equivalent to a half, how many quarters can you see is equivalent to a half? Remember, a half was equivalent to 6 marbles. So, if I were to take 2 quarters, that is the first 3 marbles and the second 3 marbles, these two sets combine to a half, and so therefore we can say 2/4 is equivalent to a half. Let us divide the marbles evenly in another way. Suppose if we had the division like this. Here we have 2 marbles in a set. But remember, the entire set was out of 12. And so, if we have 6 of these small sets, then we could recall a half consisted of 6 marbles. Then dividing it like this would mean that 3 out of 6 of these sets also represents a half. So that 3/6 is also a half. If we were to rearrange this in ascending order, then we will have a half is equivalent to 2/4, which is equivalent to 3/6, which is equivalent to 6/12. Let us look at the linear model. If we had a ruler that was divided into 12 equal parts, then 12/12 is the whole. If 12/12 is indeed the whole, then a half would be 6/12. Since the length, when divided into 2 equal halves, would give me 6 centimeters in length. Note carefully, you would have had 6 centimeters to the left and 6 centimeters to the right of the red line. Now, we are looking for equivalence to a half. If I were to further divide the ruler into 6 equal parts, how many times can you leapfrog to be equal to a half? Looking at the section to the left of the red line, we can see there are 3 out of the 6 leapfrogs. Note carefully, each of these leapfrogs are divided into equal portions of 2. And when this happens, the amount of waves or leapfrogs, we can call them, that we obtained on the left hand side is the same that we can obtain on the right hand side. So we can say there are 3 out of 6 leaps we can make. In other words, a half is equivalent to 3/6. Let us look at another arrangement. Suppose if I were to divide it equally into 4 equal parts, then we would have 2 parts on the left and 2 parts on the right. Here, since there are 4 divisions, 4 equal divisions, we can say a half is equal to 2 out of 4, since the half, let's say to the left of the red line, has 2 leapfrogs, and there are a total of 4 leapfrogs throughout the entire length of the ruler. So a half will be equal to 2/4. Using another arrangement, we can see here, if we were to divide this line into 12 equal parts, then you can clearly see that there are 6 small divisions on the left hand side of the red line and the 6 to the right hand side of the red line. This therefore concludes that a half will also be equal to 6/12. In summary, we can say a half is equivalent to 2/4, which is equivalent to 3/6, which is equivalent to 6/12. Thanks for watching. Please don't forget to like and subscribe for more videos like this. Remember, we're on the road to SEA 2021.